Tenacious test 1, question 4. You can pause the video here to check the question and play when you are done. Cool. So, Huda bought a tree, and when she originally bought the tree, or basically, yeah, when she got it, I indicated year 0. It was 130 millimeters. She then noticed the growth that the tree was getting from each year was, or it basically formed a geometric pattern. Because after the first year, it went to 100, or it grew another 100 millimeters. The year after that, it grew 70 millimeters, and the year after that, it grew 49 millimeters. This doesn't mean that the tree is getting smaller. It's growing, but it's just growing less and less each year. It's like you as a person. You start out shooting out, but when you get to the age of like 14, your growth starts to slow down and you kind of just chill at one constant height, I guess, for the rest of your life. And that's basically what happens with this tree. It gets smaller, 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 and eventually the growth is just going to like come to a halt. Yeah, at some point. So, the first question is, it basically says, during which year will the height of the tree increase by approximately 11.76 millimeters? So, basically they are saying, if it were to continue with this geometric pattern, and notice here that the ratio that is being applied is 7/10. I basically worked this out by taking the second term and dividing it by the first term. I could have very well also have taken the third term and divided it by the second term. I would still get the 7/10. And that's what it means for it to be a constant ratio. It means you get it all the way through. You won't get it for this first year though, because when she bought the tree, that amount doesn't form part of the geometric pattern. She noticed that it's only the growth that it took after that period that she bought it, that there was a geometric growth to basically that the tree took on. And so we can then predict that in the fourth year it will just be the 49 multiplied by the 7/10. In the fifth year it will be basically that amount multiplied by the 7/10, and so forth. And they are basically asking us, if it continues like this, in which year, like what will the year be when the growth actually reaches 11.76 millimeters? Okay, now what you can do is you can play around with the geometric formula. Since this is geometric growth, we'll simply just use this formula. Okay, where n is the number of the year that you are in, and Tn is the growth that it takes that year. So in the first year, our growth was 100. Okay, so A is the first year. Notice I'm not substituting this because this does not form part of my geometric pattern. So, no. It is going to become useful later though when we work out the total growth. But for now, not. The ratio is 7/10 as I pointed out, and basically this is the relationship between the year and the growth that it takes each year. So what you can do is you can play around and you can just substitute different values into that n and basically find out what n kicks out this value. So you can take out your calculator and you can fiddle around like that. But I feel a more elegant way of doing this is simply to substitute that year. Is to say, okay, if the growth is 11.76, what year does it have to be? So now you need to calculate n. And in order to do this, we're going to have to resort to some fancy stuff. But before we get to that, let's first divide by this 100. So the 11 divided by that 100 is 0.1176. We're still going to have this 7/10, which is just 0.7. You don't have to write it as a decimal. I just feel it's more appropriate since we have one over on this side. Okay, so now comes the fancy stuff. We can use log to solve this exponent. Now the log law says that if you take the exponent, that would basically be equal to log of this base, and in the other bracket, this answer over here. So basically, the exponent, n minus 1, is equal to log of, now in the little bracket, you're going to put the base, which is 0.7, and in the bigger bracket, you put the answer on this side. Okay, and that will give you a nice answer of 6, I think. Just double check for me. I think it is 6. And then you take the 1 across, that gives you 7. I feel like it will give you 6.00 some other random decimals, but it doesn't matter. It rounds off to basically 6. You take the 1 across and then you get 7. So we can find out here that in the 7th year, this is basically when the tree would grow to that, would grow this much. Okay, but eventually this amount is going to become smaller and smaller and smaller, and eventually it's going to be so small that it looks like the tree is not growing at all anymore. Okay, the next question asks us, Huda plot, or basically tells us, Huda plots the graph to represent the height hn of the tree in millimeters n years after she bought it. Determine a formula for hn. Okay, so they're saying hn, like h is a function of n. Basically, h is the height with respect to the number of years. So like in the first year, it is basically this, what she bought it for, plus the 100 which the tree grew to in the first year. Sorry, just had to adjust the camera. And in the second year, it's basically this plus this plus this, right? 70 was the growth in the second year. And 49 was the growth in the third year. I'm just having the 130 over here on the side because this was basically the height of the tree when she bought it. However, it's not part of our geometric pattern. When we talk about our geometric pattern, we're actually talking just about these values over here. Okay, but she does want to know what is a function of the total growth of the tree. So I kind of do have to include this because she bought it when it was this high, and after that, then these growths were then just added onto this. So we'll start with this, the 130. But then we need to now recognize that there's a geometric growth happening, and this is not just individual terms anymore. This is a series, so it's a sum of terms. I can't just use a Tn formula now. I need to use an Sn formula. So the Sn formula is basically a bracket 1 minus r to the power of n over 1 minus r. Okay. Remember, a is your first term. So a is the 100, the first term of the geometric pattern. And your ratio, whoops, not a plus, a minus. Your ratio is simply 7 over 10. So that's 7 over 10 to the power of n, closing my bracket, over 1 minus 7 over 10. Okay. Now, I guess you can simplify this a bit, just to make it look a bit nicer. I'm going to try to. So I basically just went ahead and said 1 minus 7 over 10 is 3 over 10. And then I kind of divided the 100 by that 3 over 10 to give me this 1000 over 3. And then when I realized it's another fraction, I just feel like it's pointless to actually do this simplification. And I guess I would just leave it as this. Or maybe let's just make that 3 over 10. But it's literally up to you how you want to leave this. Basically what this is it's a function of the height with respect to the number of years. So if you substitute n with the number of year that you are in, it's supposed to give you the total growth. So I encourage you to do this now. Substitute 4 within year. Okay, punch this entire thing into your calculator, and we are going to hope that it gives us the answer 130 plus 100 plus 70 plus 49. So the total answer is supposed to be 349. Try that quickly. Substitute in with 4. Pardon me, I mean to say substitute in with 3 and not 4. I was just counting the terms and then I said 4, but keep in mind this is not part of the geometric pattern. So 1, 2, 3, you should substitute in with 3. Also, this is year 0. So when you bought the tree, it was already this height. After the first year, first term, first year, then it grew to this, then it grew to that, then it grew to that in the third year. So this is in the third year. Substitute n with 3 and you should get this answer. Okay, that is basically the total of all these added together. And that should prove that your formula that you have over here is correct. Okay, so it does work and I am happy with that. Now, let's read the next question. It says, what height will the tree eventually reach? Okay, so what height will the tree eventually reach? Now, this is to work out the height of the tree as it progress, as the years progress. So if you want to know how high will the tree be after 3 years, you substitute n with 3 and this is your answer in millimeters. However, if you want to find out what is the eventual height of the tree, you basically want to know, like, if this tree were to last to infinity years, what is that height going to be? So it's not just the 130 plus a progression to a certain amount of years, but rather you want to add infinity years. Okay, so the sum to infinity, not just the sum to a certain number of terms. And that's why now we need to swap out this formula for the sum to infinity formula. Now, the sum to infinity formula is a very nice and neat, elegant formula, just a over 1 minus r. And since a is our first term of the geometric pattern, that should be the 100, okay? So we're saying 100 divided by 1 minus the ratio, which is 7 over 10. And for this, you can now simply just use a calculator. The answer for this alone, I think, is 333,3333333 to infinity. And if you were to add that with this, you actually get 463,33333 all the way to infinity. So I'm just putting a recurring decimal on top. But since they want me to round it off, I'll just say 3,33 millimeters. And this will basically be the eventual height that the tree grows to. Like, it would never get bigger than this. Yeah, even if it grows all the way through to infinity.